All right, so we're going to finish up looking at law of sines. Just a reminder of what the law of sines formula is. We're not going to go through the proof again. We did that yesterday. But the proof comes from taking a triangle and breaking it into two right triangles. Right, so that's what this law is really doing for you. We only use two parts of the law at one time. Right? We never use all three at the same time. There's really no new notes, just the examples. That's all we're going to do. All right, so let's see if we can solve this one. Without even making a sketch, how do we know if law of sines applies to this problem?
Because we have a full row.
Yeah, we've got a full row. So anytime you have a full row, that tells you it's law of sines. But if you want to make the sketch, you can. So here's A. Put alpha across from it. B. Beta would go across. C. And gamma. If you use the three letters to describe that triangle, what kind of triangle is it? Side angle. Yes. So side angle means, do all of you tell me, does it mean we have to check for the two solutions or no? Yeah. Okay, side angle, that's the one that's a pain, right? Pain. So side angle. We got to check for everything. And we have to find something first. What is it that I have to find first?
Beta.
Beta. Yep. You do not have enough information to find C or gamma because that's an empty row. If you've got an empty row and you can't figure out anything in it, then forget about that row for now. Find something else first. Okay, so let's find beta. All right, what's going to be my proportion that I set up to find beta?
Sine 35 over 6 equals sine
Beta.
beta over 8.
Sine beta over 8. Yep. Okay. And now my next step is going to be to do what on both sides?
Multiply by 8.
Perfect. We're going to multiply both sides by 8. And yeah, I could reduce the 8 and the 6, but again, I'm going to be typing it in on a calculator. So what's the difference if I press 8 and 6 or I press 4 and 3?
We're just doing
Same thing.
it.
Okay, so 8 sine 35 over 6 equals sine beta. But now we want beta. We want what's going to go in that box.
Take the inverse sine.
So take the inverse sine. Inverse and regular sine cancel each other out on the right. And now, whoops, sorry. Let's see what we get. So inverse sine, 8 sine 35 divided by 6. Okay, so you should have got 49.886. Okay. So now that is, what angle did we just find?
Beta.
Beta. Because this is side angle, we do have to check for a second answer. Think of that as your reference angle. What do we do with that to get an answer, to get the second answer?
180 minus 49.886.
Right. We're going to check. We need to be in quadrant 2 if there's a second answer. It'd be impossible to be in quadrant 3 or 4. That's too big. So take 180, and if you press second and do the negative symbol, it'll just take the last answer that was on the screen. So 180 minus my answer. That's 130.114. Okay, I put that off to the side. Does that angle fit with the given?
Yes.
What was the angle that was given?
35.
35. And if you add what was given to the possible second answer, it is under 180, which means the second answer fits in the triangle. Okay. Any question why it fits in the triangle this time?
So if it fits in the triangle, then that counts as the second answer.
Yep.
So would you get two answers for gamma?
Right.
Yeah.
So now, the way we're going to do this, it doubles the fun, and we get to find 2 of everything. So basically, we're going to be doing 2 problems now. So this would count as 6 questions on the test, 6 answers. So this one would be worth quite a few points because you can get partial credit for everything you get right. Yep.
Because there's 2 betas, would there be 2 B's or no?
No.
Okay.
You don't have to worry about anything that was given.
Okay.
Anything that was given
It's
is
just the same that it
is
stays?
done.
Okay.
Yep.
So is it guaranteed that there will be 2 answers for every single one?
No.
Okay, so we're just looking for the ones that do fit together.
Well, yesterday we did the case where you had the possibility of 2 answers and the second one did not fit.
Okay.
Today we're doing the 2-answer one where it does fit.
Got it.
So some have second answers, some don't. Yeah. Okay, so now let's put that answer down. If you want to think of this in terms of like kind of color coding what we're doing, let's call the first problem we're doing the blue problem. So that angle is in the blue triangle. That angle is in the blue triangle. And that angle is in the blue triangle. Those are the 3 angles in the first problem. In the, I don't know, call it the green problem. Alpha is in the green problem. Beta 2 is in the green problem. And so is gamma 2. So alpha is an angle that's in both. It was given, so it's shared. Anything that's given is shared between both problems we're solving right now. So same thing for the sides. A is in the blue problem. B is the other side in the blue problem. And so is C1. So those are the 6 pieces of information that are in the blue problem. And the 6 pieces of information in the green problem. A, B, and C2. So you could make 2 separate tables and just repeat these top 3 pieces. I do it like this. I just do it all in one table. Okay, so now let's find gamma 1. How are we going to figure out gamma 1?
180 minus 49.886 plus alpha, so 35.
Yeah, so you're going to take 180, you're going to subtract out the 49.886, and then subtract out the 35, which is basically what you said, 95.114. Okay, so that's the last angle in that one. Now we're going to find gamma 2. What 2 angles am I going to use to get gamma 2?
B2 and 35.
So 130.114 and then 35, and you subtract them from 180.
Yeah. So what does 35 and 130 add up to?
165.114.
So we'll do 180 minus 165,114. That gives me 14,886. So we are now done all the angles in both problems. Now we have to finish off the sides. Doesn't matter which side you do first, you can do either one. Let's do C1. C1 is in the, well, we're calling it the blue problem. So that means we need to start with a blue row that has everything in it. Don't use a green row because that's the other problem. What's a row that's blue and has both pieces of information?
A and alpha.
Yeah, A and alpha, that's perfect. It's actually in both of them. So that one you can use. sine 35 over 6 equals, and what's going to go on the other side to find C1?
Sine of 95.114 over C.
Over C1. Okay, cross multiply, and then we'll have our answer for C1. So 6 sine 95.114 divided by sine 35. That gives you 10.419. Okay, so there's C1. Okay, and the last thing we have to find is
C2.
C2. So let's find C2. So sine. And now C2, that's in what we call the second problem, or the green problem. Okay. What is a row that's green and has everything in it?
Again, you can use A and alpha.
Yep, then we'd use the sine of 35 over 6. And for C2, what's going to go on the right side?
Sine 14.886 over C2.
14,886 over C2. Okay, so let's type that in. So it's going to be 6 sine 14.886, 14.886 divided by sine 35. Okay, so that gives us 2.687. Okay, so I don't think a two-solution problem is harder. I think it's longer. You have to basically do everything twice. But again, that would be worth a lot of points. That'd be 6 questions, 6 answers on the test. All right. So any questions how we went through that problem?
How did we get V2? I mean, sorry,
How did we get?
C2?
huh?
C2?
Yeah, how'd you get C2?
C2. So we use sine 35 over 6 because we have to use a row that has everything in it. And then we did sine of, if you're finding C2, you need gamma 2. If you're finding C1, you use gamma 1.
Okay.
So since we're finding C2, I did sine of 14 divided by C2. And then I cross multiplied. This times this, and then equals that times that.
Okay.
And that's what I typed in.
To the calculator, and that's what you get the answer.
That's how I got that.
Thank you.
Yep. Okay, anything else on that one? So I want to look at, like, physically how that could happen. How could I give you 2 sides and an angle and have you make 2 different triangles? So like if I physically gave you like objects and said, here, build a triangle with these 2 sides and this angle. If I gave you this information, some of you might build the first triangle when you put the sticks together to make it, and some of you might end up building the second one. Right? So let's look at how that could happen. So this is side, side, angle. All right, so first, if I make a copy of that side, does everybody agree that side and that side are still the same? Okay. So the triangle that I'm building right now has a side in common with the top one. Okay. I need it to have another side. So I'm going to take this side, and I'm going to flip it. And I'm going to put it right there. Okay. When I flip it, does the length of that side remain the same as the length of that side?
Yes.
Yeah, it's just flipped. Okay. But if you were to measure it, they're still exactly the same length. So now this triangle has 2 sides in common, 2 sides exactly the same as the top one. Okay. The only thing I can do left is just connect the third side. So how does that, well, it's okay, it's close enough. How does that give me an angle? that's in common? Well, if you look at your triangle and you move it up here, look at the lower left. In the lower left, they are exactly the same angle. So this angle is exactly the same size as that angle. That's how you can draw two completely different triangles, even though they each have two sides, exactly the same length, and one angle, exactly the same. And that's the only case that you can do that with. There's no other case you can get two answers with. Any questions on how I physically drew that? So the top one, I don't know which one is which, because that drawing is not to scale with this problem. But the top picture, that might be like the blue triangle problem. And the bottom picture, that's the green triangle problem. Something like that. Okay. So that's the two solution piece. All right, let's look at this one. Right. How can we tell that this is law of sines without a sketch?
You have one full row.
Yep, we have one full row. And you can also tell that it's the case we don't like to deal with because you have one completely empty row and you have no way to get anything in that row. That's how we can tell it's the one that is kind of a pain to work with. All right. So because of that, what do we have to try to figure out first? Yes. So we're going to try to find alpha and see what happens. What would go on the left side?
Sine 50 over 1.
Sine 50 over 1. And the right side?
Sine alpha over 2.
Perfect. Sine alpha over 2. And our next step, so we can start to get alpha by itself.
Multiply by 2.
Multiply by 2. Times 2. You don't even need this divided by 1 because dividing by 1, that doesn't change anything. So we can just write 2 sine 50 equals sine alpha. And now to get rid of sine, we're going to use
Inverse sine.
inverse sine. So inverse sine and regular sine cancel each other out. Nothing cancels on the left. You just have to type the whole thing in. Now, let's check 2 sine 50. Let's just see what that is. Okay, 2 sine 50. It's 1.5.
There's going to be no solution.
Yeah, we're going to be trying to take the inverse sine of a number that is bigger than 1. Okay? If you tried to do that without checking, well, you would get this. You get a domain error. It's not between -1 and 1. So, because we tried to take the inverse sine of something that's bigger than 1, what do you think that means about alpha?
There's no solution.
There is no solution for alpha. Now, if you can't get a solution for alpha, then you have no angle to add to 50 and then subtract from 180.
So there's no solution for beta.
So we can't get beta.
And there's no solution for b either.
Yeah, if you can't get the angle, then you can't get the side that's across from the angle. So it's either all one solution, all two solutions, or all no solution. And this particular one is no solution. Okay. Any question why that's no solution?
Could you explain why it's not a solution?
So it's not a solution because when you set up your equation and you try to take the inverse sine at the end, you're trying to take the inverse sine of a number that is bigger than 1. If you try to do that, you're going to get a domain error.
Oh, because it says 2 sine.
Right.
Okay.
If it was like 1 sine 50, then that would have worked fine. But 2 sine 50 does not.
So anything bigger than 1, then it can't work.
Right. If this comes out bigger than 1, right there, that whole thing, it won't work when you do inverse sine. Yep. It also won't work if it's lower than -1. But this number would never be negative in a triangle. That's impossible. Because you'd never have a negative side length, and you'd never have an angle that would be in quadrant 3 or 4. So you'll never have to deal with it being smaller than -1. So what would happen if you draw that then?
And there would be no congruency between the two angles.
So what would that like look like if we try to draw this? So I showed you what happens when you try to draw the two solution case. You get two
Wouldn't it just be
pictures.
two sides and then no like third side?
Well, you can't draw it because then, like, you don't have three of the parts to draw the.
You'd have like the 1 and 2, but like the 50-degree angle wouldn't touch the other.
Yeah, it wouldn't touch any of them.
It wouldn't touch, it wouldn't connect.
Because we
Yeah.
don't know the other two angles.
The triangle would look kind of open. So if, let me draw this one, and I will draw it perfectly to scale.
Wait, so you can do sine, if it was not to sine 50, you could do it, do sine 50?
Yeah, if this side wasn't a 2, like if this side was maybe like a 1.3 or something, then yeah, I could do it. There's lots of numbers that it could have been and it would have worked, but 2 is not one of them.
So you cannot inverse sine something bigger than 1, is that what you said?
Right, you can't take the inverse sign of something bigger than 1. Yeah.
Or less than -1?
Yep, but it'll never be -1 in this kind of
Yeah,
situation.
okay.
So let's draw what we were given. We had a side of 1 and a side of 2. Right? That just means one side is twice as long as the other. Doesn't matter what I use, 1 inch, 1 foot, 1 centimeter. Just I need a 1 and I need a 2. All right? Whatever unit you want to use. So let's call that 1, and let's put 2 of them together, and then we'll call it 2. Okay? And I'm going to group those together. All right, so that's 1 unit long, that's 2 units long. The side that's 1 unit long is C. The side that's 2 units long is A. So A is the longer one. What I did is I used a protractor already, and I drew, that's exactly a 50-degree angle. It's not an estimate, that's exactly what it is. I need to make sure this side is exactly at a 50-degree angle or pretty close. That's it's close enough. Okay, I can't turn that now. I have to keep it tilted like that. If I don't, it's not at 50. Okay, it has to be at 50 because that was given. Right. Now, side C is 1 unit long. Side C is somewhere off that. Okay, so I just have to connect it somewhere over here. I can turn it however I want, but to turn it, I have to group it with something. Because right now, I don't have the little green handle on it. So it's kind of weird, but if I group it, now I got the little green handle. Now I can actually erase it. But now I can rotate it. So, okay, so I can put that any way I want. You want to do it like that? Fine. But I cannot lengthen it. Okay? It has to stay that long. Now, side B, they didn't give me. So you can make side B as long or as short as you want. Okay, if you want to put side B like that, fine. But you can't tilt side B because you have to maintain this 50-degree angle right there. So if I do that, no matter how I turn this last side, try to turn it like that, it's never quite going to reach. I can shorten this if I want, but it's still not going to reach. To make this problem work, I would have had to do maybe one of a few different things. One, allow this angle right here to not be 50, so I could tilt it up. Maybe allow that angle to be like 20. Then that would have worked. Or I could, if I was allowed to make this side longer, I could make it work. Or if I was allowed to make this side shorter, I could make it work. But you're not allowed to do any of those things because they were given. So there's nothing I can do to make this triangle connect. That's a no solution problem. Okay. Any question why it's a no solution? But that's what it looks like visually.
So the reason why it can't be closed is because all the sides have to be that size for the reason?
Well, the only side length you can change in this problem is the bottom one. Because that's the only side that wasn't given. So you're allowed to do whatever you want for the length of that side. But you can't change these two.
Okay. And that's why it can never be a full triangle.
Well, that combined with the fact that I also am not allowed to change this angle either,
Okay.
because that was also given.
So those are just duct tape.
Yeah, there's nothing I can do to make a triangle out of that information.
Sorry, I thought, isn't gamma supposed to be in front of C, not next to it?
Yeah, C would be over here somewhere. So gamma would be across from C.
Okay.
Yep. And beta would be up here. And because you weren't given beta, you can make that angle anything you want. But I don't care what you make it, it's never going to work. Yeah. All right, so that's a no solution. All right. So, what gets you more excited? Hiking, like maybe trying to like find somebody in the wilderness, or like being in the ocean?
Ocean.
The ocean. Okay. So we'll do the ocean problem.
I love trees.
We'll do the ocean problem.
We're having fun.
Yeah, this is fun. Okay, so what this problem is basically going to be about is there's going to be, just to kind of set the whole thing up, there's a boat somewhere out on the water, and the boat, they need help. They don't have GPS working, and it's cloudy, so they can't see stars or anything, and it's nighttime, so they can't see any landmarks. So it's maybe
Really rough.
they got a rough thing going on. But they at least have a light on their boat, and the light works. So they call the Coast Guard station, and the Coast Guard station says, "Well, start turning your light on and off so we can see it blinking." And the Coast Guard station sees the light, way in the distance. And the Coast Guard station is going to tell the boat where they are. All right? But in order for that to work, if only one Coast Guard station can see the boat, they can't tell the boat where they are. 2 Coast Guard stations have to see the boat at the same time. And then they can both work together and tell the boat, here is where you are. If you have a compass, go in this direction, and you'll head towards land.
Can we take a
Okay?
trip to the beach?
To try it on the beach?
Yeah.
Not today, though.
Oh.
Maybe someday, we'll have to see.
Maybe tomorrow.
So, there's 2 Coast Guard stations, just to abbreviate them, we'll call them Zulu, and the other one is going to be called X-Ray. So, Coast Guard Station Zulu and X-Ray are 120 miles apart. Okay, how would you know that? Well, I mean, how do you know Boston and Worcester are a certain number of miles apart? You just look that up on a map. So they're known points on a map. Okay, so these 2 Coast Guard stations are along the shoreline, and it does tell you which one is west, or in our case, to the left of the other. Okay, so we're going to have to set that up. And how would we know the direction from each Coast Guard station to the boat? Well, if the boat has a light on it and they turn it on, if you're standing at the Coast Guard station, you can look at a compass and look at the light and be like, oh, the light's coming from that way. So you can figure out the direction the light is coming from. Okay, so each station can see the light, and for one station, the direction of the light is 40 degrees east of north. Okay, what does that mean? Well, here's your compass.
I don't like that either.
East of north means it's to the right. Okay, that's east of north. That's a direction 40 degrees to the east of north. You could also say that that is 50 degrees north of east. You can say it the other way too, right? That's 50 degrees above east, or north of east. Say it either way. Okay, so for one Coast Guard station, it's coming in east of north. And for the other station, it's coming in west of north. Because it's coming in from different directions, that means the boat is between the 2 stations, right? It's like for me, one of my, if I was the object you were trying to find, for some of you, I'm to your left. For others of you, I'm to your right. And the reason I'm to the left of some of you and to the right of others is because I'm in the middle of you. That's why. All right, so the question is, how far is each Coast Guard station from the ship? Okay, so there's a lot of description to try to do a problem like that. What's going to make this easier to start to understand it all? Yeah, it's a lot easier if we draw it out. And the hope is that when we draw it, we end up with some type of triangle in the diagram. All right? So I'll scroll back up. But what's something very important that we need as an object in this problem?
Zulu and X-ray.
Yeah, we need the 2 Coast Guard stations. And where are the Coast Guard stations generally if you're looking at like water and land?
They're on the edge.
They're on land, right? They'll be like on the edge of the land. Right? In fact. Okay, so the first thing we've got is we've got our beach, and we've got
Yeah, we do.
2 Coast Guard stations. It says Zulu is to the west, which would be what direction on the screen here?
The left.
The left. Okay. So this is 1 Coast Guard station. We'll put it right there, Zulu. And the other Coast Guard station is over here
In the woods.
in the woods, and that's X-ray. So there are 2 Coast Guard stations. How far apart are they?
120 miles.
Okay, so if I put a line between them, they are 120 miles apart. Okay, so now we have a boat out here somewhere. There's our boat. And our boat can be seen from each Coast Guard station. Okay, so what I'm going to do is draw a line that represents the direction that they can look in and see the boat. Okay, so that's the direction for one of them. That's the direction for the other one. All right, now it says the direction to the boat from station Zulu is 40 degrees east of north. So let's draw in like an imaginary line that represents north. Okay, right about there. Okay. So 40 degrees to the east of north. That's north. Okay. 40 degrees to the east is right there. So the direction is 40 degrees like to the right of north. Okay. Now, do the same thing for the other Coast Guard station.
But on the other side.
Draw a line. And what's the direction for them?
30 west of north, so it would
30.
be on the inside.
So that's north again. So it's 30 west of north. So the question is to find the distance from each station to the boat. Well, the triangle we're working with is right in here. There's our triangle. Okay, let's move that down and see what we can start labeling. Okay, we know the bottom side is 120. Okay, anything else that I can label in that triangle?
The 40 degrees and the 50 degrees.
No,
'cause
so
that's the
you would
opposite.
subtract the
So it's
40 from
50.
90.
So it's 50 and 60.
Right, that's the angle we really want to work with, 50 and 60. And now we've got 3 pieces of information. Angle, side, angle. That is not the type where we have to worry about 2 solutions. Let's label everything. A, B, C. If you want to use other labels, you can. I'm just using the labels we're used to using. What would the 50-degree angle be? That would be labeled beta. And the 60-degree angle? Alpha. And the one at the top? Gamma. Okay. So now we're going to solve that triangle for A and B. Let's go like that. Okay, let's. It doesn't matter which one we we do first. This time I'm not going to set up a table. I want you to just kind of remember the idea of law of sines. It's sine of an angle divided by what is across from it. So we could do sine of, oh, we're going to figure something out, and sine of, we have to figure out something else. In that picture, do we have an angle and the side across from it?
No.
No. Is there a way we could figure something out? So we
Yeah.
would.
Yes.
Yeah. What could we figure out?
180
Gamma.
minus 110
Yeah.
for gamma.
These add up to 110, which means gamma would be
70.
70. Okay. Now, do we have an angle and the side across from it?
Yes.
Yes, then we can set up law of sines. What could we start with on the left side? And this would represent a full row.
Sine 70 over 120.
Sine 70 over 120. So this is going to be find A. And then we'll do it again to find B. We're going to be able to use that row twice. What would go on the right side if we want to find A?
Sine 60 over 8.
Sine 60 over A. And what would go on the right side if we want to find B?
Sine 50 over B.
Sine 50 over B. Okay. Now it's just a matter of cross multiplying to get each answer. So let's cross multiply and see what we get. So we have 120 times sine 60 divided by sine 70. So that gives us a distance of 110.59 miles. Okay, and why would they want to know the distance? Well, if they know the distance, then they can tell the boat exactly where they are. Okay? But one station by themselves could not. Okay, all one station could say is the direction they see the boat in, but they would have no idea how far away the boat is. They just see like a speck of light. They don't know if that's like a mile away or a mile and a half or 2 miles. They don't know. But with two stations, you can triangulate exactly where the object is. All right, and for station B, or well, side B, we're going to do 120 sine 50 divided by sine 70. Okay, so it's 97.82 miles. And that's the distance that each Coast Guard station is from the boat. So specifically, with Zulu was Zulu to the boat is side A. So Zulu to the boat is 110.59 miles, and X-ray to the boat is 97.82. Okay. Any question on that? Now, this assumes a few things. First of all, it assumes that the boat is staying perfectly still. Okay. In reality, unless the boat was able to anchor itself, it might not be able to stay perfectly still. Like if it had an engine problem, it might be drifting. So they have to account for where it's drifting. So in reality, what they would probably do is say, set up like a margin of error. So they'd set up like almost like when you see like a forecast for like a hurricane or something, they show you like where the hurricane is and kind of where it'll be. But the further they try to predict, the more error there is and where the hurricane might go. So same thing here. They might say, we're going to imagine the boat and give a margin of error like that. So what that does is it gives them a search area. They say the boat should probably be somewhere in that zone. And then the Coast Guard does a very systematic way of searching. Which there's a whole, it's actually kind of neat how the Coast Guard finds somebody that they don't know where they are, how they go about searching. It's not just random, it's pretty like a method they use to search for something. But we're not getting into anything that fancy. We're just assuming the boat stays exactly still, doesn't move, makes the problem a little simpler for us. Any questions on those two numbers? All right. So that's law of sines. Generally, word problems only have one solution because we're usually solving something that's real life, and it would be impossible to have two different locations for the boat. The boat is only in one spot. It's not in two spots at the same time. So generally, word problems that we do are one solution. Okay. So those are the questions for tonight. It's not really like a range of questions, it's just some individual ones. So 4, 9, 11, 13, 14, 18, and 19. It is possible you get some questions with a no solution. Possible you get some with no solution, two solution. Anything we've studied over the past day for side-side angles.